Well, hi, good morning. Thank you so much for joining me here in my shop. It's May 7th today, and here's another radio I'm going to start with today. I don't know anything about it other than what the note says up here. What's the note say? Does nothing. Does nothing. There's a smaller note here. Not suitable for something. Will fade in sunlight. Will fade in sunlight. Wow. Well, the knob doesn't look very good, but same thing with this knob. The rest of it looks pretty uniform in color. It's just dirty. It's very dirty. Does nothing. Well, that's just right up my alley. That's a great thing. Let's look in here. This has been done correctly. It looks like this screw is something's going on there. Loose as can be. Oh yeah, these are loose. Wow, it's really loose. Okay, well, that'll do the trick for now. Okay, it's a non-polarized plug. If you notice on this radio, I was going to say there's no metal sticking out. There's a whole bunch right here sticking out. There's a screw right here. The knobs are probably of the recessed type. I'll pull it off eventually. Phono input. Hey, what is this? Phone radio, it's called. The phone radio. Listen. Speak. What? Radio. Phone? What are they talking about here? Oh, there's a whole bunch written on the back, but it's so hard to see. Sylvania, this radio provided, I can't read this, provided with an interlock to prevent dangerous electrocution and shock. Do not tamper with the interlock. 5 tubes, including rectifier. Something down here. Well, phone radio. Listen and speak. Listen. It's spring-loaded. Hello. No answer. Radio. Phone. Listen and speak. Hello, who's there? So the idea is this is sitting on your desk, and the phone rings, and you flip this button to phone, and then you're listening, and you go, hello. Come on, this can't be the way this works. They've never seen anything like this. Where's the phone plug-in? Well, oh, it's original Bluetooth. Oh, that's really curious. Unless phone is just short for phono, but that doesn't make sense either, because it doesn't say phono anywhere, does it? Radio phone. Speak. Well, you're plugging something in here, and I don't know. This is the weirdest little radio. Okay, well, let's not get too excited. Now, there's some penciled in writing here. Somebody's written 35 here. Somebody circled this. This is the tube diagram. It's very hard to see in the camera. You really can't see it, but there you can see the penciled circle. Somebody circled a tube. What for? This is the Sylvania Electric Canada Limited. Where's that? Dunville? Dunville. I don't think they're making radios in Dunville. Dunville, Ontario. Wow, how do you like that? I have no idea. I've never had a radio from Dunville. Dunville is a small city on Lake Erie, on the north shore of Lake Erie, if I remember right. So it has the defense symbols on it here. There's another one there. It's a little worn out. That's an American thing. So why does this Canadian radio have that? We had no such system here, I'm pretty sure, in Canada. auxiliary unit socket. That's what this must be, the auxiliary unit socket. Antenna. This radio has a special self-contained antenna system. It's not just an antenna, it's an antenna system designed to provide excellent reception. Since this antenna works best in some positions, turning the radio slightly in either direction may improve reception. Okay, very well said. Is there any other notes I'm missing here? Some secret about the... maybe this is a secret phone. Maybe this is a spy radio. Of course, they wouldn't write the instructions on a spy radio, would they? Attention spies. No spy serviceable parts inside here. What do? Do we plug this guy in and find out for ourselves what it does? That it does nothing? Yes, I can do that. Should we look inside first and just see what's in there? You know what? It's probably worth doing because it's just a little bit silly to not have taken a look. For all I know, there's tubes missing in here. It's a 5-tube set, so the tubes heaters are in series. They're right across the line, so together they drop the entire line voltage, 115, 117 volts. Some of the tubes drop more voltage than others, usually the rectifier tube and the output tube. These two tubes need hotter filaments or heaters because they are conducting so much current. Consequently, they have more power. Since the same current is flowing through all 5 tubes, it's the same current, the same, probably 50 milliamps, but I'm not sure. I could easily be wrong about that. Okay, we're going to try to take this off. The antenna, hold on. The antenna is on the back of the radio, so that's only part of the picture, is it? Oh, I got to take the knobs off, yeah. Oh, there's this screw too, this side screw. One screw into the side, probably to stabilize this. Oh, 2 screws, there's another screw right there. Okay, off you come. Oh, what happened there? It came off, but it didn't come off. Oh boy, what happened? What's it holding on to? I'm already in trouble with this. Come on, really? You know what it is? It can't come out the hole. There's a locking washer on the shaft here to keep this from coming right out. Why bother with that? He says, just in the same way. Well, you know what? The radio's here after all these years and it still has its knob, so maybe there's a good reason for that. Now, do we have to do this? I would think so. We certainly do. Wait a minute. No, we don't. So this whole structure here, including the ear or the jack here, is all on its own little metal piece. So I think we can leave that for now. Any other radio come out already? Oh, this came out. Okay, that's a good start. And there's a screw holding it in there. Oh my gosh, it's a filthy, dirty guy. It's filthy and dirty. It's filthy and dirty. There we go. Now, unfortunately, these plastic radios, chances are really good at breaking bits of plastic off them, especially when doing anything powerful to them. Pulling on stuff, putting in screws. Now it's going to come out. Well, actually, it's not going to come out. Oh my gosh, it's really complicated in there. Look what they've done here. They've got a little transformer here of some sort, but there's the speaker transformer. What's that all about? So these are on with clips, so I can pull this off. Apparently not. Doesn't want to come off. pull this out. This piece has to come with it. And you know, now there's, looks like I can pull off the speaker. Somebody has soldered this one on. Take the speaker out too. Everything's coming out. We're going to make everything come out. Okay? That's what you're asking for. Square head screws. Canadian thing. So I guess this radio was made, there was some notion it would be sold in the States. And that's why they put on the... yeah, I think this has to go. Civil defense frequencies. I remember visiting the United States when I was 19 or 20. And noticing, it might have been in Washington, that a lot of the buildings had these symbols on the front of them, and then it would say 40 people or 20 people or something like that. And I realized, oh, those are all basically nuclear bomb shelters or places to run to with the number of people they could hold. Nothing like that went on here in Canada. That duck and cover thing that children were taught, not taught here in Canada. So, you know what? These wires are soldered on also. The slide-on connectors have been soldered. There's one screw going to the speaker I'm not going to be able to get at without a tremendous amount of work. So we'll leave the speaker there for now and see what all will come out at this point. So I know people talk a lot about the Cold War now, but during that period of time not a lot was said about it. I mean, it was mentioned as a thing, but to me, I thought they were just referring to, you know, these wires are too short going to the speaker to pull it out. So what can I do here? Cut the wires to the speaker and then fix them later? Try harder to get the speaker out. There's one screw here, one screw there. Is there one down here? No. So they've only... cheap, right? There's 4 holes, but they only use 2 screws on the opposite corners. Just boss, we're going to save lots of money here. Only need the 2 screws, not the 4. Bill, there'll be a little more in your paycheck. The easiest thing is to cut them. Another possibility is to try to unsolder these connectors here. Just put the soldering on. You know, that's probably the neatest way to do it. Well, were they soldered in the factory? I'm going to guess so. I don't think anybody's been in here with a soldering iron since. They put them together and then decided they were unreliable and had them soldered. Must be the case. I make up so many stories. But that's what we do as people, right? We see things happening and we want to know the story. It must be a story. Oh, was I going to plug this in and try it? As is? As was? Yeah. Yeah, I'm going to try it. Now, the reason I can try this without too much worry is because I have a way of restricting the power going into the radio. Okay, yeah, I almost forgot that. Now, you might think, oh, what are you doing that for? Don't you want to fix it up first? Well, actually, no. I don't want to fix it up first. I want to find out what condition it's in, and if it works at all. And then while I'm doing repairs, I can check back and see if it's still operating as poorly as it was, or if it's gotten better, or if it's gotten worse. So, oh, wait a minute now. I don't have the volume control. No control on the volume. There we go. There we go. Okay, so I'm going to feed power to this. It's going to go through these 2 light bulbs that are sitting here. At least, I'm going to start with one light, just this one. That's going to keep the current from being too high. Okay, first test, we apply power and we see if it all shows up. 112 volts. That's all of it today. A little low, isn't it? Just give it a touch boost. 114. Now, as soon as I hit the switch here, this will drop way off because there'll be voltage dropping on this light. Let's see what happens. Jingo. Oh my gosh, they're right. It does nothing. Maybe watch this. Oh, my knob came out. So there's no change in the supply voltage. No current being drawn by this radio at all. Now, why would that be? Defective tube with an open heater. Because all the tubes are in series. One goes open, they all go dark. Okay, so they were telling the truth about the does nothing. Just trying to hold back the innards here. There we go. Hold back the innards. Now that's not something you'd want to hear your surgeon say. So now we're going to try to undo those. 2 wires to the speaker. What am I going to do? I'm just going to... Now you've been standing in one spot this whole video. I bet you your legs are getting sore. Come on over here. Now you're a little hunched over. Just like me. Not hunched over to do the work. I'm not hunched over normally. Okay, grab that wire. Melt that solder. Pull that thing off. Here we go. How about this one? Grip it. I don't really see solder on this. That's very awkward. Very awkward. Maybe I can pull this tube out. And then if I do this, I can lever it on the tube socket. Okay, it complained a bit. Now, should be able to pull this whole thing out. Antenna, this piece. Everybody coming? I said, no, not everybody's coming. There's still another wire. What the heck is this one now? There's 2 more wires. What is going on here? Oh, this must have something to do with these switches over here because we've got this transformer. I've got this one up here. You have the voice coil terminals here, where my fingers are, and the wires from the voice coil terminals head into the switch arrangement. There's one down here. Like this one voice coil terminal is only connected into where? Into the switch here. Well, I think when we study the schematic, assuming we can get a hold of one, we'll be able to sort that out. Now, I have to take a little photograph of that before I... No, I don't. I've got it on video. Don't need a photograph. Actually, I can use my video to take a photograph. I almost never do. I think I'm going to do it this time, though. Get a picture of the situation there. Because later I'm going to disconnect some wires, and later I'm going to have to reconnect them. So I'm going to take that photograph and trying to work my... There it goes. Okay. Good. Now I'm going to cut those wires off. I'm going to cut them off right at the terminals. I'm going to leave a little bit, and that'll tell me, once again, reaffirm what color and all that. Cut the one down here. So those are the, you know what, this isn't going to work either, because this is going to start coming out. It's got more wires going over here. I will discombobulate the unit. Oh, maybe I can get at that screw now. That bottom speaker screw. Not really. We should check to see if these tubes were in the right place before I go too much further. This tall one was in the this position. Which position is it? Wait a minute here. Yeah, it would be this one. What's that say? 50. I think it says 50 there. Let's take a look. 50C5, and the other one I've pulled out, 12AT. Wow, looks like it's 8, but I think it should be 6. This would be a 12AT6, and the tall one. What did I do with the tall one now? There it is. That's going to be a 50C5. Okay, so right tube's right place. Not too surprising. Yeah, right, so I'm going after that screw. Going after that screw. That's not the right size. Let's go with this one. Oh boy. What I'm expecting is a sudden crack. Nope, here it comes. Crack right here. This crack goes right to the edge here. Okay, got one screw out. There it goes. Okay, now the other one. It'll come in this way. This way, because the screws seem to be kind of loose in here. Didn't feel quite right. Let me try a different one. I have a number of red handle guys. Oh, that's even worse for the angle. Well, this just kind of fell out. Did I knock that one out? Or was it already falling out? Is this the reason why it didn't work? It's the only one with the shield on it. I'm pretty sure this has to be original. Well, I'm going to leave it there for now. You know what? I've got the power onto the outlet here. Should leave that on. So what were they thinking somebody would do with this radio? How did they manage to put it together with all this stuff way up in here? Is there a trick here I am failing to catch on to? Yeah, just pull this out a little further and further. Yeah, that's the trick. Just pull it out further. Okay. Get a better alignment on the screwdriver. Not really. This thing's in the way. Can I pull this right out? The answer is no. This yellow wire is what's really. Oh, yeah, this whole thing comes first too. Yeah, bingo. There we go. Suddenly, the puzzle solves itself. Shebang. Putting this back together is going to be a nightmare. put these screws back in, you want to make very, very sure they go back into the same threads. You know what? I don't have to take it right out. I think it's hanging on it. No, it's not. There we go. Okay. All parts out. Nothing in there, no information. Nothing. Okay, I'll just set that aside. Wow, here it is. Here is the radio. Let me put all these screws and stuff in the screw bucket. I think probably the next step is to take a look at the schematic and just see what all is going on. What's this phone thing? Look at that antenna. Tell me a machine, tell me a person did this. No way. Look at that, square corners. Big blob here. Big blob there. And these two terminals. This one is connected to the wire right here. The inside wire. It looks like this is connected to the inside wire. Okay, a little bit of mystery there, but not too much. Now, what about the circuit board itself? Seems okay, just looking at it. I don't see anything obvious going on. A little bit darkened in here where the tube is. The hot tube is right in here. And you can see it's gone dark a wee bit. At least I can see it with my eyes. That just it kind of gives an indication of how much the radio was used. How much? I don't know. You can put this like this. That's just a little neater. We've got one of these bad guys here. So this piece is a very early, I call it an integrated circuit, but they had a different name for it. I think they called it a package or something like that. And inside here will be the 3-4 capacitors, a couple of resistors. And this is usually in the circuit just past the volume control, where there's inevitably a little network of resistors and capacitors. And some manufacturer thought, hey, we can make these things and sell them to the radio makers. And say, hey, you don't have to put all these components in, they're all inside this little package. And I really think that was the start of the integrated circuit. Integrated circuits are a little different today because they're not like this. And this is actually discrete components inside there. It's not a wafer of silicon or anything like that. So while I'm talking here, I'm looking. Don't see anything too outrageous here. I can sort of guess this guy, well, you know, he's in a metal can here. It might still be okay. Next step's got to be test the tubes and find the bad tube, because I believe that's really the root of the problem with this radio. Oh my gosh, what if I just switched the tube and the whole thing worked fine? I took it all apart. You know, thinking of things a little late in the game there, Jim. Oh well. Yeah, tube testing is next. Let me just see if I'm going to do that today. It's getting a little late in the morning already. Okay, first tube we're going to do is a 50C5. There's a good chance this is the bad guy anyway, but who knows? Let's double check. 50C5, 47 for the filament voltage, 4 signal level, bias 12H, and then the numbers 1576G. 1576G. 4300, 4300, 32. Plate is on C. A pass, or the recheck point for this tube is 1220, about here. On the dial. There we go. Okay, now watch the pilot light. Oh, did you see it go dull? Maybe you didn't in the camera. I don't know. I wasn't looking. But that's a good way to tell quickly if the filament is drawing power or not. So it is. Do the line check here. Okay, it's showing a little low, and that's because the heavy draw from the tube, probably, or maybe the generators are turning slow today. Okay, I can see the heater too. Now I'll do the short test. Okay, the meter didn't move at all. What was that? I don't know, just bouncing along. And we're ready for the test. Once again, we test the reject point. The throw it away point is 1220. So 1200 is about here. Below my finger. Oh, she's a goodie. She's a goodie. That's good. That's good. That's a good output tube. Okay, next one we'll do is the 12AT6. Okay, I'll get this set up for it. Okay, let's just double check before I plug this in. 12AT6. Set to 13 on the voltage, 1 on the signal, 28L on the bias, 51760, 51760, 0300, 0300, 35 on the meter setting, F for the plate, and we're good to go. This is a two-part tube. The first part we're testing is a triode amplifier. The other part is a diode. 1 or 2 diodes. Looks like 2 diodes. Triode and 2 diodes. That's very typical for a detector tube. Okay, let's look for any shorts in here. I can see it's heated up. So this isn't the dead tube by any means. And this guy, he's got to get up to 780, so he's got to get up here. There we go. Ooh, he's a weakie. He's a weakling. He's a weakling. Oh my gosh, really weak. Let's just double check the settings to make sure everything's correct. 28L, yep. And over here, 35, yep. Well, I think we got a very weak tube here. I won't even bother testing the diodes because the triode. So this amplifies the signal coming right off the volume control just after being detected. So if this guy's weak, the output of the speaker is going to be weak. But it's not dead. He's not dead. Close to it, but not quite dead. Okay, pull out another tube. Well, let's do another most likely dead tube, which is the rectifier tube. No, you know what? We're going to stay in the 12s. I'm sorry, I'm changing my mind. It's easier if I just do the next 12 one. 12BE6. 12BE6. Okay, so I can't get this set up for the 12BE6 here. Okay, let's double check before I plug it in. 12BE6. 13 for 8L on the bias. 51763, 51763. 3000. 4100. C. She's ready for a test. Here we go. Does the little light flash? Yep. Flickered. It did flicker. I can see it glowing very nicely. Any shorts in here? No shorts. If there was, the meter would go up and stay up. This guy should reach 1570 on this test. So 1570 is just past the halfway mark on the meter. Hoo-yah! Why, one so good, one so bad? How's that happen? How does that happen? Now we'll do the rectifier tube. No, wait, this isn't the rectifier tube I'm holding. This is the rectifier tube. skinny little thing inside. Hardly. Okay. This is supposed to be, let me just read it right off it. 35W4. That's got to be correct. So I'm going to double check again. 35W4. Yep, that's what it's called for. 35W4. Okay, I'm going to set this guy up for that. And we'll double check it. Okay, here we go with a test of the rectifier tube. Let's just double check here. 35W4, 35 volts on the filament. It's a rectifier, so you don't need to worry about that or the bias. The numbers are 00763, 00763, 0100, 0100, 25 on the meter adjustment, and E for the plate. Here we go. Now these tubes, rectifier tubes, test differently than the signal tubes and a tube tester. A good tube tester actually measures the, I don't want to say amplification, but measures the mutual conductance or transconductance of the tube and reports that on the meter. You can't do that with a rectifier. There is no amplification, there is no transconductance or reverse resistance in a rectifier tube. So the regular tube, we're pushing this button, but for this we got to push this guy here. It says rectifier and diodes. And then the rating is marked right on here, which I'm sure you can't see, but it has to come up past my finger when we go to do the test. Now, this tube, you know what? It has not heated up. There's no heat in that tube. It's a dud. It's a dud, I bet. There we go. 3, 2, 1. It's a dud. Now, is it really, or did I just fail to? Sometimes I have trouble here on me. So I'm watching the green light and moving this. No, she's finished. It's a dead tube. There it is. We found it. This is the reason why the radio is not working at all. 35W4. They're a little bit rare, but I'm pretty sure I've got some. So I'll be able to replace that. That leaves 1 weak tube, 1 dead tube, and 1 more to go. And this one's hiding in its shell here. I've got to get it out. And, these are not the easiest things to get out, by the way. And I don't know if I don't want to do this on the camera. I'm going to kind of peel it open a little bit and push the tube through. Yeah, a little bit. Not quite sure why I made that weird sound just now. Yeah. Make use of all your fingers in some clever way. I haven't got the clever way. Okay, another way is if you turn this one way, it will actually open the thing a little bit. So maybe we can do that. Holding on to the pins, which isn't the best idea. Okay, that didn't work very good. I don't want to bend the pins either. Hey, this is a silly problem. And pushing on that little point of glass, and it hurts. Where's the edge? Here it is. And if you get these things open enough, the tube literally drops out. Oh, must be 9:43. It's 9:43, everybody. Part way out. Well, maybe that's enough for now, because I think we'd be pretty sure what tube that is. The beeping will stop in a moment. The tube must be a 12 BA6 is what I would imagine. Let me just trying to read this here. Now this is the circled tube. What? 12 BA6, and they have a cover on it. Okay, 12 BA6 is usually just the IF amplifier tube. No harm putting a cover on it like that. Well, I don't think anybody's done anything to this, so it's come out of the factory just the way we see it. So they put a cover on it. 12 BA6. Here we go. 13 is the setting. It's a 12-volt tube, but the number they have on there is 13 for some reason. I always wondered about that. 410L, L10, 10L, 52763. 52763. 4120, 4120, 33. Now you've been watching me do this, so I don't think I need to double check it, because you would have said something. You would have said, "Hey, you got that wrong." But you know what? I didn't hear anything from you at all, so I'm going to double check anyway. 13 on the filament volts, 4 signal level, 10L bias, 52763. 52763. 4120, 4120, 33. We're good. Let's see, here we go. This is I hope this is a 12BA6. Did I bend the pin? I must have bent the pins a little bit. Now typically only one tube is going to have its filament burned out, because as soon as the filament burns out, that's it for any current flow through any tubes. So you would not expect to find 2 dead tubes in here. Oops, there we go. How about a shorted though? Could be shorted, never know. No sign of anything going on there. 12BA6, this should come up to 960. So just short of the 1,000, up about here. And it's a weak one. He's weak. Now wait a minute. Is it really weak, or did I have this set wrong? Oh, never throw a tube out unless you're absolutely sure. 52763. Yeah, those will be correct. It's the 10L and the 33. Let's do a little study here. How sensitive are these? So watching the pointer, and I just turn this a little bit, not much. That's not going to get you up to the good graces for this tube. And what about the bias? Also not. So even if the bias is not accurate, or I've set it slightly off, it's not going to. You're done, Mr. Tube. You've reached the end of your time, and I don't know what you've been doing. Some of your buddies seem okay. Well, maybe they got changed earlier. Maybe. I think probably in the typical life of a tube radio, tubes got changed. I don't think too many tube radios went their entire life until retirement with the original tubes, unless they got no service, unless they weren't used. Oh, I can't pull that out. Well, I will get it out, not to worry. Okay, so that's the tube testing. That's the tube testing done. And we have 3 dogs. Three dogs, 2 good ones and 3 dogs. So that's it for today. Where is it? Should I put new tubes in and make this thing work? Yeah, I'm hesitant because it takes a bit of time to dig the tubes up. And what time is it here? Well, I'm going to stop, have a coffee, and think about that. Okay, so here's a good 35W4. I just tested it. I'll put that in there. That is the right spot for it. Yes, it is. This bad one, I'm going to bend a pin right away on it. That's my way of avoiding putting this back in my collection by accident, because guess what? 4 or 5 tubes on my bench and they got all mixed up, and before you know it, I don't know what's going on. So now, we need a speaker connected, rather than, oh my gosh. So this is where the transformer is. Or is this where the transformer is? I think I better reconnect the speaker the way it was intended. Because right now there isn't even a wire going to the. Yeah, so I'm gonna have to solder the black and the green and put these 2 back on. Is there some? So it looks like the red one was there. Yeah, okay. Well, this is awkward. We do clip leads on some of these, but I think I'm gonna want to should do clip leads on all of them. It's clip lead time. Okay, let me clip lead all this up. Okay, I think I'm just about ready to go. Let's just double check clip leads. Going to the green wire. Green wire, yes. Going to the black wire, yes. 2 leads from the speakers are going to the terminals on the board. Yes. Okay, this is a little bit of a loosey-goosey way of doing this. Could be trouble with the clip leads and stuff like that, but all we want to do is just see if this radio will work at all at this point. And I only give it partial hope. Ooh, that was a kind of a dumb thing to do. What did I wreck up now? Did I wreck anything up? Yanking on that? So I can't really plug this in. Well, maybe I can. Yeah, I think I can. And the power's off. Power's off. Okay, yeah, that's plugged in. Clip leads are still intact. Okay, man. Now, next we have volume controls and stuff like that. Let's just go around like this. Put my fingers in here. Let's switch it on. Now, first we want to test it off to make sure off is off. Okay. I'd suggest you just stand back a little bit from that. Here we go. Power is on. 113 big ones coming at it. Nothing happening. Perfect. Okay, power off. Switch on. Switch on. There we are. Turn the volume up a little bit. Now, what we might get out of this is just a roaring hum. Maybe the only thing we're going to hear. Are we ready for that? Speaker's not shorted. Okay, here we go. Now, do you see that dim light really come on bright? Let's give it a bit of time. 38 volts on the radio, that's not enough to make it do anything. 50 volts. Slowly the heaters are heating up. They heat up very slowly when you're using a dim bulb. It takes a long time. 62 volts, it's probably not enough to make any sound. But you know, it's drawing power. I mean, changing the 1 tube has made it draw power. 67. So we're not going to get there with one light. Now I'm going to screw in the other light bulb. They're just in parallel, so there'll be 2 paths. It's going to increase the voltage over here and the current flow to it dramatically. It's going to go right up almost to the top. The thing about these bulbs is, if a short develops in here, the bulbs will come on bright and I won't have a circuit breaker popping in my house. And plus we'll see that right away. So I'm going to screw this bulb in. I'm sure they're just going to be dark when I do that. And can you see the voltage? Yeah, watch this voltage jump up and hear the radio. How's the predictions? Pretty good. Where's the hear the radio part? Where's that part? Hear the radio. Have I done something dumb? Okay, I'm going to put my ear on that speaker. Seems to be absolutely dead. Oh, I've probably got these switches in the wrong spot. Okay, power off. Power off. These switches here. I left it on. Oh, which way did it go now? This is the... which way did it go? Oh, this is great. Oh yeah, it's got to be like that. And so this thing must tip up like that. So the top one is set to listen, and the bottom one is set to phone. Phone. Nobody's phoning me on this radio. What would my phone number be on this radio? Here, try again. The volume is set just up a little bit. Now there was no sound out of the speaker at all, so let's just look at these clip leads again. The key ones are this wire and the green wire. They're connected. Okay, here we go again. Boom. The booming sound was me. It wasn't the radio. What happened? Oh yeah, it's coming on. Come on, speaker, make some sound. I hear something. I do hear something. Let's get a little more volume. Ooh. Okay, so my clip leading has probably got trouble. That could have been the problem the first time around. There's enough volume there. Let's tune this radio. Oh, it's very hard to turn this, but it's working. Okay, station's down here. Let's give it just a little more volume. There it is. Directional antenna. It's not clear enough to understand what he's saying. Unfortunately, in my shop, this is the worst place to operate radios. Really, they're just terrible. But let's try. Another station. Give me the big dial. Where's that big dial? Oh, the big dial is stuck in the radio cabinet. Do I have an instant dial handy? I kind of do. Well, this may look good enough, maybe. I don't know. Yeah, that's going to do it, even though it's totally loose. Okay, here we go. So, starting at what would be probably 5:30. Here we go. I think there's a voice there. Yep.
For the summer, but I alluded to some of the standings. David, why don't you give us the full breakdown on what we did last week and where we're at in our contest, which ends today between the three of us. Please don't, Dave.
How about that?
I was going to say. Bring up the editing sauce. We should. Awesome.
Okay, that's great. I'm going to shut it off here.
You know what? Oscar was the top dog.
Okay, so the sad part of the story is all I had to do was change one tube and it would have worked, and I didn't have to take this out of the cabinet. I didn't have to do all this crazy stuff I did. None of it had to be done. I just had to find and change the dead tube. Duh. So there's no consequence, I don't think. I'll put it all back together and it'll be fine. I probably won't do any changing of any parts in this radio at all. My goal with these radios is to get them working of a minimum of effort and a minimum of investment. The next person who owns this radio can go to town on it if they wish, but at least it's in working condition, which tells them the IF transformers are good and all the parts are there, and that integrated circuit thing is not a problem, and all that kind of stuff. So that's where I got to, just with one tube. And now it's all splayed out on my bench. Okay, well, I'll have to put it all back together, and I'm not going to do that on video. I'll do that on my own time. So thanks a lot for watching. that's it for this radio. I'm not going to do more component changes or anything. That's it. It's done. Thanks a lot for watching, and I'll see you on the next video.